Hi guys! Welcome back to my channel. So for today's video, I'm going to share with you the content and summary of what I've learned in CCNAv7 Module 10. So guys, I have here a PowerPoint presentation about the content of Module 10 for you to be able to understand the topics well. CCNAv7 Bridging SRWE course, or the Switching, Routing, and Wireless Essentials. Module 10 is all about the LAN security concepts. So, the objective of this module is to explain how vulnerabilities compromise LAN security. Topic titles: Endpoint Security, Access Control, Layer 2 Security Threats, MAC Address Table Attack, LAN Attacks. So those are the topic titles of this module, LAN Security Concepts. Module 10.1, Endpoint Security. How to use endpoint security to mitigate attacks. So what is an endpoint security? When we say endpoint security or endpoint protection, it is an approach to the protection of computer networks that are remotely bridged to client devices. The connection of laptops, tablets, mobile phones, and other wireless devices to corporate networks creates attack paths for security threats. So, endpoint security software protects these points of entry from risky activity and or malicious attack. When companies can ensure endpoint compliance with data security standards, they can maintain greater control over the growing number and type of access points to the network. Endpoints are hosts which commonly consist of laptops, desktops, servers, and IP phones, as well as employee-owned devices that are typically referred to as bring-your-own devices or BIODs. Endpoints are particularly susceptible to malware-related attacks that originate through email or web browsing. These endpoints have typically used traditional host-based security features such as antivirus or anti-malware, host-based firewalls, and host-based intrusion prevention systems or HIPS. However, today endpoints are best protected by a combination of NAC, host-based AMP software, an email security appliance or ESA, and a web security appliance or WSA. Advanced malware protection or AMP products include endpoint solutions such as Cisco AMP for endpoints. Increasingly, enterprises and their employees are incorporating practices to make access to data more fluid. The increase in BIOD or bring your own device policies, in addition to threats targeting mobile device access and networks, create multiple endpoint vulnerabilities. In addition, employees working from home or connecting to Wi-Fi networks to work on the go means that the enterprise network security perimeter is more porous than ever. In the past, most security breaches came in through the network. Today, however, threats are increasingly coming in through endpoints, which means centralized network protection does not go far enough. Shifting security perimeters that lack clear definition require new layers of security through endpoint protection. Security must maintain greater control over access points to prevent the vulnerabilities that can arise through the use of remote devices. Module 10.2 Access Control. Explain how AAA and 802.1x are used to authenticate LAN endpoints and devices. AAA stands for Authentication, Authorization, and Accounting. The AAA concept is similar to using a credit card. The credit card identifies who can use it, how much that user can spend, and keeps an account of what items or services the user purchased. AAA provides the primary framework to set up access control on a network device. AAA is a way to control who is permitted to access a network, authenticate, what they can do while they are there, authorized, and to audit what actions they perform while accessing the network, accounting. The IEEE 802.1x standard is a port-based access control and authentication protocol. This protocol restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. Many types of authentication can be performed on networking devices, and each method offers varying levels of security. The simplest method of remote access authentication is to configure a login and password combination on console, VTY lines, and AUX ports as shown in the VTY lines in the following example. R1 config sharp line VTY04 or 04, R1 config dash line sharp password CI5C0 or Cisco, R1 config line sharp login. With 802.1x port-based authentication, the devices in the network have specific roles as shown in the figure. The diagram shows the devices involved in 802.1x port-based authentication. On the left is the supplicant, in this case a desktop, which requires access and response to requests from a switch. Requires access and response to requests from switch. The supplicant is connected to the authenticator, in this case a switch, which controls physical access to the network based on client authentication status. So the authenticator is connected to the authentication server, which performs client authentication. The supplicant, authenticator, and the authentication. Client supplicant. This is a device running 802.1x compliant client software, which is available for wired or wireless devices. Switch or authenticator. The switch acts as an intermediary between the client and the authentication server. It requests identifying information from the client, verifies that information with the authentication server, and relays a response to the client. Another device that could act as authenticator is wireless access point. So, authentication server. This one. The server validates the identity of the client and notifies the switch or wireless access point that the client is not authorized to access the LAN and switch services. Module 10.3, Layer 2 Security Threats. Identify Layer 2 vulnerabilities. We learn about ways to secure the LAN by focusing on the frames found in the data link layer, or layer 2, and the switch. Recall that the OSI reference model is divided into 7 layers which work independently of each other. So, security is only as strong as the weakest link in the system, and layer 2 is considered to be that weak link. This is because LANs were traditionally under the administrative control of a single organization. We inherently trusted all persons and devices connected to our LAN. Today, with BIOD, or the bring your own device, and more sophisticated attacks, our LANs have become more vulnerable to penetration. Therefore, in addition to protecting layer 3 to layer 7, network security professionals must also mitigate attacks to the layer 2 LAN infrastructure. So take a look in this picture. As you can see, network administrators routinely implement security solutions to protect the elements in layer 3 up to the layer 7. They use VPNs, firewalls, and IPs devices to protect these elements. And however, if layer 2 is compromised, then all the layers above it are also affected. For example, if a threat actor with access to the internal network captured layer 2 frames, then all the security implemented on the layers above would be useless. The threat actor could cause a lot of damage on the layer 2 LAN networking infrastructure. Security is only as strong as the weakest link in the system, as I have said earlier, and layer 2 is considered to be that weak link. This is because LANs were traditionally under the administrative control of a single organization. The first step in mitigating attacks on the layer 2 infrastructure is to understand the underlying operation of layer 2 and the threats posed by the layer 2 infrastructure. IPSG is a mitigation technique that prevents MAC and IP addresses spoofing. Port security is the mitigation technique that prevents many types of attacks, including MAC address table overflow and DHCP starvation attacks. So those are some of the related topics according to Module 10. And next, Module 10.4, MAC address table attack. Explain how a MAC address table attack compromises LAN security. So, to mitigate MAC address table overflow attacks, network administrators must implement port security. Port security will only allow a specified number of source MAC addresses to be learned on the port. Port security is further discussed in another module or in the next module. All MAC tables have a fixed size and consequently, a switch can run out of resources in which to store MAC addresses. A MAC address flooding attacks take advantage of this limitation by bombarding the switch with fake source MAC addresses until the switch MAC address table is full. When this occurs, the switch treats the frame as an unknown unicast and begins to flood all incoming traffic out of ports on the same VLAN without referencing the MAC table. This condition now allows a threat actor to capture all of the frames sent from one host to another on the local LAN or local VLAN. Module 10.5 LAN attacks. Explain how LAN attacks compromise LAN security. This topic investigates the many different types of LAN attacks and their mitigation techniques. Like the previous topics, these attacks tends to be specific to switches and layer 2. A VLAN hopping attack enables traffic from one VLAN to be seen by another VLAN without the aid of a router. So for my next video, I will be uploading the Module 11 to Module 13. So see you guys on my next video. Thank you for listening and watching. God bless!